Solve the problem based on work done in isothermal process. So in this process, isothermal process, we know the formula, that is during the isothermal process, work done by the system is equal to minus 2.303 nRT log V2 by V1, where V2 is the final volume and V1 is the final initial volume of the gas. So based on this, we will see some problems. Let us see these problems. Calculate the work done by a gas when its mole means 0.5 at 27 degrees centigrade expands from 5 liter to 25 liter reversibly and isothermally. So for this, we know that work done during isothermal reversal process is minus 2.303. So this is work done by gas or by systems, and RT and a log of V final divided by Vi. So just put this value, because given here 25 liters final volume, initial volume 5 liters, mole is given here, temperature given here, so we can directly put value and we will get answers 2.303. N is 0.5, 8.314, and temperature is 327 degrees centigrade, and log is 25 divided by 5. So on solving, we will get answer here minus 2 into 10 power 3 joule, or we can say minus 2 kilojoule. So this is basically our answer. So here 2 moles of a perfect gas are expanded isothermally and reversibly from 5 atmosphere to 1 atmosphere. So high pressure to lower pressure, that is expanded. Then when pressure is given, then it is expanded. Work done is there at this temperature. Calculate the expansion work done during the process and report. 2 questions given. First is the expansion work done, and second is you have to report the work done for compression if the same process is reversed. So first process is expansion, because pressure is decreasing. So on decrease of pressure, so we have to find the work done of the total process, that is the work done is equal to minus 2.303 and RT in the log of P initial by P final. So here you have to keep in mind initial or final, but in case of volume, we are writing volume V final by V initial. So just put this value, so we will get here value minus 2.303, and here N is 2 mole, and R we know that 8.314, and temperature 300, and log of final volume, final pressure, initial pressure is 5, and final is 1, so it is decreasing. On decreasing, it will increase. So here total value will be 8029 joule, or we can say that it is 8 in kilojoule, 8.029 kilojoule. Okay, so this value was the work done given by the expansion. Okay, so this is the expansion. We can say this is the expansion. So a compression will be, so compression, if you see compression, so for compression the work done will be just reverse of this one. So for compression numerical will be so for compression numerical value of the work done will remain the same, but sign will be changed. So work done will be positive. So here work done during compression will be here 8.029 kilojoule. Only sign will be positive. So keep in mind, for if you are taking compression, okay, so this become this value, and for expansion, so this become this value. So only there is a reverse of sign. 10 gram of helium at 127 degrees centigrade is expanded isothermally from 100 atmosphere to 1 atmosphere. So here pressure decreasing means it is expansion. So calculate the work done when the expansion is carried out. So we have to carry out, first is the single step. So first is the single step, and second is in 3 steps the intermediate pressures being 60 and 30 atmosphere respectively, and third is the reversibly. So we have to find out 3 questions. One is the single step, when in 3 steps, and third is the reversibly. So again, what is the initial pressure, what is the final pressure, that is given here 100 atmosphere, 5 atmosphere, 1 atmosphere, it is given here. Most of the gas will be most of the helium gas will be, that is 10, they have given here 10 gram of helium. So moles of helium will be your 10 by, that is 4 gram of helium, so this becomes 2.4 mole, and temperature we know that 400 Kelvin. Temperature is 400 Kelvin. Now work done. So work done will be equal to how much? So it will be your V delta P. This is the work done. For the single step we have to find out. So here first we have to know how much volume is given, because volume is not given in this question. So we have to find first volume. So use the ideal gas equation. So volume of the gas, you can see here volume of the gas is equal to this one, that is N into R into P into initial pressure. So here you will get the volume. So on solving 2.5, here it will be 8.314 multiplied by 400 and divided by 100 into 10 to the power 5 Pascal, because if you take Pascal then you use the value of R. So here you will get the volume, that is 83.14 into 10 to the power minus 5 meter cube. Now work done. So we can put this value over here. So in this case 83.14 into 10 to the 14 into 10 to the power minus 5, and again multiplied by pressure is initial pressure 100 minus 1 into 10 to the power 5. So on solving we will get minus 8, not minus, plus 8230.86 joule. Okay, so this is our work done by the gas in one step. It's work done by the gas in one step. Now in 3 steps. So for 3 steps, just bring this value here. Second is our in 3 steps. So in 3 steps, for first step, what was the volume? For first step volume was 83.14 into 10 to the power minus 5 volume. So this was the volume in first step. So again for the pressure is how much? The pressure from 100 atmosphere we are decreasing to 60. So here change in pressure will be how much? 100 to 60. So it will becomes pressure. So for this work done will be how much? So V into delta P. So here V is already given in 83.14 into 10 to the power minus 5 into 100 minus 60. Okay, and into 10 to the power 5. So on solving you will get here 3325.6 joule. So this is the work done in second process. Okay, this is work done. Now again what is the volume? So in this case for second work done volume will be changed. So again V will be an RT by pressure. Okay, so here you can push the second pressure. So a value is here 2.5 moles of the helium, 8.314, and temperature is again 400. So this isothermal process and pressure is 16 into 10 power 5. So on solving we will get here 138.56 into 10 to the power minus 5 meter cube. Okay, up now come to, this is the second step. So we are going, so change in pressure again 60 to 30. So we are going to for third steps. So this is the work done. Volume. So again change in pressure. So change in pressure will be now 60 to 30. So 100 minus, no, so not 100, it will be 60 to 30. So this is the total pressure. So into 10 to the power 5. Okay, and second case, if you see here, delta P. So again here work done in second case will be 138. Okay, 138.56. that we find the volume. This is the volume second case we have just discussed here. If you see, go back, we see here 138.5 with this is the volume, just we find out. So after this multiplied by 10 power minus 5. So this will be into 60 minus 30 into 10 power 5. Okay, so that is nothing but the pressure into volume, change volume. So here we will get volume 4156.80 joule. Okay, now in third step, so what is the volume? So volume will be nRT by pressure. So N is 2.5 and here R is 8.314. Again temperature is 400 and pressure is 30 into 10 to the power 5. Okay, so on solving you will get here 277.13 into 10 to the power minus 5 meter cube. Okay, now in this case what will be the change in pressure. The change in pressure will be here again 30 minus 1 into 10 to the power 5. So work done in third case will be 277.13 into 10 to the power minus 5 into 30 minus 1, okay, into 10 to the power 5. So here we will get work done 8036.77 joule. Okay, so we got work done. This is the work done third, so this is the work done 2, and we have work done 1 also. Work done 1 we discussed long back. Here work done 1, okay, this is work done 2, this is work done 2, this is the work done 1, and we have one more work done, is that is here work done is 3. So work done total will be how much? So work done total will be work done 1 plus work done 2 and plus work done 3. Okay, so we'll get answers 3325.6 plus 4156.80, okay, and plus 8036.77. so total work done will be 15519.17 joule. Okay, now third question was that reversible process. So third was reversal process. For reversal process again 2.3, because that was the compression, this was the expansion. So here for reversal process, same formula we can use, nRT by log of pi by pf. Okay, so here 2.303 and is given here 2.5 moles and 8.314, and temperature is again 400 and pressure is 100 by 1. So on solving we will get answer 38294.28 joule. Okay, so numerically what when work done in all the parts of the process is maximum work done can be obtained during the reversal process. So this is the maximum work done, and this is the different types of work done. So there is difference in work done. So this is difference in work done. This is maximum part of the work done that you have to keep in mind. So here at 27 degrees centigrade, 1 mole of the ideal gas is compressed isothermally and reversibly from the pressure of 2 atmosphere to 10 atmosphere. So low pressure to higher pressure is there. So the gas has been compressed. So what is the work done? So work done is so isothermal process, so minus 2.303, okay, into so nRT log of so P initial by P final. So we can directly put value minus 2.3 into 1 into, so 2 is the R value, temperature is 300 and log of 2 by 10. So on solving we will get answer here 965.84 calories. So this is our answer. Now for isothermal chain, if it is isothermal, so in this case delta U will be 0. Okay, so from first law of thermodynamics says that, first law what says that Q is equal to delta U minus W. So again U is 0, so this become minus 965.84 calorie. So Q is equal to minus 965.84 calorie. So this is the value of Q, this is the value of U, and this is the work done given by the gas on compression. So in this case 1 mole of the ideal gas is heated at constant pressure from 0 degree centigrade to 100 degree centigrade. So number A question, calculate the work done. Number second, if the gas were expanded isothermally and reversibly at 0 degree centigrade from 1 atmosphere to some other pressure, P total is given. So what must be the final volume if the maximum work is equal to the work involved in A? A means calculate the work. So for this we have to find out. So first we have to find out what is the work involved in heating the gas. That is nothing but the P is equal to, first we have to find out work done involved in heating the gas. So this is the general formula, minus P into change in volume, so V2 minus V1. Okay, so but here volume they have not given here, so but other things they have mentioned, that is the temperature, initial pressures and all these things. So we can convert this pressure into volume into nRT2 minus P. P is the common only, and V is your nR T1, and P is the common here. So PP can be cancelled. So on P cancel, you will get here minus N R, and this will be your T2 minus T1. So we can directly write this value minus 1 into 1.987, and temperature is 373 minus 273. So on solving, we will get here minus 198.7 Kelvin. So this is our work done. Okay, this is our calorie work done. Now second part is there. Second part, because the work done is used in reversible isothermal expansion at 0 degree centigrade. Okay, so work done in reversible process used up, so it will be minus 2.303 nRT, again log, so P1 by P2, initial pressure by final pressure. So here work done used, so how much work done used? It same work done, 198.7 calorie minus 2.303, and this is 1 mole of gas, so this will be your 2 kilocalorie, and temperature is again 273, and log initial pressure again 1, and P2 we have to find out. P2 we have to find out. So each thing is given over here. Okay, so one more thing. So if you solve it, so on solving here we will get here, so P2 will be 0.694 atmosphere. Okay, so P2 is given, so you will get this value over here. So this is the final pressure if the maximum work done is equal to work involved in the A. So this is our answers. So here 1 mole of the ideal gas undergoes reversible expansion, isothermal expansion, from initial volume V1 to final volume 10 V1, and does 10 kilojoule of work. The initial pressure were 10/7 Pascal. So calculate the V1. If 2 moles of gas were there, what must be the temperature has been. So here we have given 2 questions. So for volume is V1 is given here. Second 10 joules of work done, they also given here 10 kilojoule. Okay, so we have to find out what is the V1. So to find the V1, okay, so here to find the V1 work done given, so if you use this equation, work done is equal to minus 2.303 nRT. Okay, log of V2 by V1 we cannot find out because V1 given here in terms of V1 and V10 V1, so we have to use the formula, this one, pressure, second formula, that is minus 2.303 nR log of P1 by P2. So in this case work done is given here. So what is the work done? So 10 kilojoule, this is given here, 10 kilojoule, 10 into minus 10 into 10^3. So this is the work done by the gas. It is the work done by the system, we can write here. So this equal to minus 2.3, and N is given 1, and R is 1, 8.314, and temperature is T, and log of given here initial temperature. So P1 is given here already, that is the 10^7, but we don't know the second pressure. So 10^7 divided by P2. P2 we don't know. Okay, so here we can find out P2 also, no problem, but again this is there 2 values given. So first we find out what is P2. So now we can use to find P2, we can use here Boyle's law. So in Boyle's law, that is volume is given, pressure is given. So P1 V1 equal to P2 V2, P1 V1 is equal to P2 V2, and P1 is 10^7 into V1, and this will be your P2 into 10 into V1. So definitely here P2, because this will be cancelled. So P2 will be 10^7 divided by 10, this will be 10^6 Pascal. Now we can put this P2 value over here. So we put here, so we'll get here minus 2.303 into 8.314 log of T into log, T into log 10^7 divided by 10 to the power 6. So this is the value. So on solving, so we get the value T is equal to 522.27 Kelvin. So this is the our temperature there. Okay, this is our temperature there. So what is the volume? So volume will be how much? So we can find the volume over here. Use the ideal gas equations. Just keep this one. ideal gas equation. So PV equal to N into R into T. Okay, so now in this case P pressure is given here 10 to the power 7 into V1, okay, and 1 into 8.314 into temperature is 522.27. so in this case we'll get the value V1 is equal to 4.31 into 10 power minus 4 meter cube. Now second question was given, if the moles is, if the gas is using 2 moles, okay, so in that case what will be the temperature? So temperature will remain same only. So again in this case, so temperature initially was how much? 522.27. so just you divide by 2, okay, so it will becomes here 261.13 Kelvin. Okay, so we can use this value. Where this value comes? So this value comes from here, W equal to minus 2.303 into nRT log of P1 by P2. so in this case what happens, this is constant, okay, this is constant, only changing this one. So N1 T1 equal to N1 T2. so by using this one we will get this value. So this is our second answer.